Okay, segments and triangles test review. Let's go. All right, so number one, given that M is the perpendicular bisector of PQ, okay, which means that this side and this side should be congruent because it's a bisector. PS is 4Z, okay, and then QS is 2Z plus 26. All right, and so we see that those two are congruent to each other, so that's going to be 4Z equals 2Z plus 26, and we're going to solve for Z, and we get 13, and then we're going to plug those back in. So for PS, we'll have 4 times 13, which equals 52, and then for QS, we have 2 times 13 plus 26, which also equals 52. So it says to find QS, and there it is. Number 2. Given that line T is the perpendicular bisector of JK, so again, if that's the perpendicular bisector, that means that those two are congruent. And since this is clearly an isosceles triangle, these are also congruent. JG is x plus 12. KG is 3x minus 17. So by labeling the figure, I can see exactly what's going on. This is obviously a part equals part. And number 1 was also part equals part. I didn't write that down, sorry. And that's going to be 3x minus 17. Okay, if you use NSolve, or if you solve it by hand, it doesn't really matter. You should get x equals 14.5. And then we plug it back in. So for GJ, we have 14.5 plus 12, which would be 26.5. And then for GK, that would be 3 times 14.5 minus 17, which also equals 26.5. So I do both of them so I can check my work, and since they're both equal to each other, we're good. And the instructions say to find KG. KG and GK are the same thing, so this will be the answer. Number 3. Line M is the perpendicular bisector of segment PQ, which means that this side and this side are congruent. So this is going to be another part equals part problem. So this is 4x plus 35 equals 6x plus 25. And when we solve for x, we get x equals 5. And then you will plug it back in as always. So PT equals 4 times 5 plus 35, which is going to be 55. And PT or TQ, doesn't really matter, is going to be 6 times 5 plus 25, which is also 55. And the question says to find x. We did that, so I'm going to put a box around it. And it also says to find PQ. Well, PQ, we didn't calculate that, but we can because it's the whole thing. So if this side is 55 and this side is 55, we just add them together and we get 110, which would be our second answer. Number 4. Ray BD is the perpendicular bisector of AC, which means these two sides are congruent. So that's going to be another part equals part problem. So we have 5x minus 6 equals 3x plus 8. And if we solve for x, we get x equals 7. Then we're going to plug it back in as usual. CD equals 5 times 7 minus 6, which would be 29. DA or AD, doesn't matter, equals 3 times 7 plus 8, which also equals 29. The question is asking us to find AC, which would be the whole thing. So if this part is 29 and this part is 29, you simply add them together to get AC. And that would be 58. All right, number 5. Point D is the circumcenter. So since this says circumcenter, that means we are dealing with a perpendicular bisector problem yet again. And it also means all three of these are congruent to each other. So let's see what the problem says. AD is 40x minus 11, and BD is 24x plus 37. So again, those two are congruent to each other. And if you use those cheat notes that I gave you, you'll know that for perpendicular bisector, it should have been part equals part anyway. All right, so we just make them equal to each other since it's part equals part. And we're going to solve for x. So in solving for x, we get x equals 3. All right, and then we plug it back in just to make sure we did it right and also to figure out the answer. So BD was 24 times x plus 37. And that was 109. And then for AD, that is 40 times 3 minus 11. And again, that is 109. And then the question's asking for DC or CD. And again, it should be the same as both of these. Okay, so it's still 109. Number 6, G is the centroid. So since this says centroid, this is a median problem. All right, so let's see what it has to offer. AF is 24. So this part right here, that segment is 24. And then it wants us to find GF. So we don't know GF, but we do know that the whole thing is 24. Now, if you look on your list that I gave you of all the equation types for centroids and medians, you will see that this is we have a long part over here that we don't really care about for this problem. And then this missing part is what we call the short part, and then 24 is the whole thing. So the only equation that uses short and whole is that the short side equals 1/3 of the whole thing. S equals 1/3 W. So I don't know the short side yet, but I do know that the whole thing is 24. And so I'm just going to do that, and that gives me 8. So GF is 8. All right, moving right along. So again, we're still dealing with medians. Since that says centroid, I'm going to erase this so I can start fresh. All right, G is the centroid. Okay, EC, that's this segment here, is 81. So the whole thing is 81. And it wants us to find GC, which is this part right here. And this is G, if you can't tell. So I hope it's kind of obvious, but this is the long part. And then this over here is the short part. And then 81 would be the whole thing. The question does not ask us about the short part. It asks us about GC or CG. All right, so this part, this problem is asking us for the long and the whole. It's referencing the long side and the whole thing. So the only equation that has both of those only would be this equation. Excuse me, that is a mistake. 2/3 whole. All right, so if we plug in what we know, we don't know the long side yet, but we do know the whole thing is 81. And once we do that, we get that. The long side is 54. So 2/3 times 81 is 54. And of course, you can just type that in your calculator. Let me show you real quick. So in your calculator, you would just do the fraction button, 2/3. Make sure you hit the right arrow, and then times 81, enter. And you can see there it's 54. All right, number 8, point G is the centroid. Again, this is a median problem, and point G is the centroid. If DG is 12, find GB. So let me go ahead and erase all of that. DG, so that's this little part right here, is 12. And we're asked to find GB. We don't know. Now, you can tell by looking, this is the long, this is the short. The only equation that has long and short only is long equals 2 times short. So the long side we don't know, but we do know it's going to be 2 times the short side. So since the short side is 12, the long side is 24. So GB is 24 units long. Okay, moving on to number 9. Point G is the centroid. So again, this is another median problem. All right, DG is 8. That's that part right there. GB is 2x plus 4. And we need to figure out x. So again, this part up here is the long part. This part down here is the short. So 8 is the short part. 2x plus 4 is the long part. So again, we're going to need to use this equation. That's the only equation that only has long and short. So, and we don't want the whole thing because we don't know the whole thing. All right, so the long part was 2x plus 4 equals 2 times the short part, which is just 8. And that is what you need to type into your calculator for NSolve. And I'll be nice and do this one time for you. Okay, so we're going to go to the little book thing, get to numerical solve. We're going to type 2x plus 4 equals, you can type 16 or you can put 2 times 8, it doesn't really matter, comma x, and we get 6. So x equals 6. And the only thing it asked us to find was x, so we are done. Number 10. All right, so we're given a few different things. It tells us that QY and PX are both medians, and it wants us to find n. Now, if I try to use this bit, it says that this thing is 4n minus 26. So that's not going to be too helpful because I don't know what this side is equal to. So I'm going to focus my attention on PX because PX gives me the long, right? This part right here. And it also gives me the short, which is the 27. And again, this is a medians problem, so that's why I'm using long and short. Okay, so we know that L equals 2S, or 2 times S. So the long side equals 2 times the short side. All right, and when you use NSolve, you can use NSolve and you don't actually have to put n, you can just use x instead and you can type it like this, okay, and then put the comma x like that. So you can do that, that's absolutely fine. You don't have to use n. So for this one you should get n equals 18.5 when you use NSolve. And that's the only thing that it asked us to do, so we're good. Number 11, find the altitude of the equilateral triangle with a side length of 20. So here's my equilateral triangle. This is 20, this is 20, this is 20. And we need to find the altitude. Since it says altitude, we know it's obviously an altitude problem, so let me draw the altitude. Boom. Now, since this is an equilateral triangle, we know that this is 10 and this is 10 because, the whole thing has to be 20. So I'm just going to get rid of that 20. Okay. And the way, if you look on that cheat sheet that I gave you, we're going to use the Pythagorean theorem for this one. So whenever they're asking for the altitude of an equilateral triangle, just use Pythagorean theorem. So we're going to use A equals the square root of C squared minus B squared, which is a derivative of, A squared plus B squared equals C squared. That's where we get that from. Anyway, so we're going to call this A. This is going to be B. This is going to be C because it's across from the right angle. And we don't know A, but we do know that C is 20. So that's going to be 20 squared minus 10 squared because 10 was B. And when you enter that into your calculator, you should get 17.3. Okay, and that's all it asked us to find. It just said find the altitude. Number 12, same thing. So I'm going to draw my equilateral triangle. Okay, and it has side lengths of 14. So again, we're looking for the altitude, so I'm just going to go ahead and draw that altitude right now. And since it is an equilateral triangle, I know each side has to be 7 because it does need to add up to 14. The whole thing has to be 14 because all 3 sides are equal. Anyhow, this is, again, since it's an altitude problem and it's an equilateral triangle, we can use Pythagorean theorem to find the altitude. So whenever you're looking for the altitude, use Pythagorean theorem. So again, I'm going to use this form of the Pythagorean theorem. Excuse me, that should be minus. Did I put minus for number 11? Because I should have. Okay, good. Just making sure. All right, so again, this is going to be A for altitude. This is B, and this is C because it's across from the right angle. So A equals the square root of 14 squared minus 7 squared. And when you type that into your calculator, let me just show you because some of y'all still try to use NSOLVE for like everything. And it's ridiculous because you don't need it for everything. So since A is already by itself, all we're going to do is put the square root of 14 squared minus 7 squared. Do not use NSOLVE for problems like this. So we get 12.1. We're just going to round that to 0.1. So for number 12, we get 12.1. Okay. So that is that. Moving on to 13.